Welcome to the Airvolt Deep Dive, the series where we break down the convergence of climate technology, digital media, and verifiable accountability.
Okay, the deep dive is on. We are here today looking at quite a stack of sources, actually. We've got technical reports, investment decks, market analysis, all centered on this one climate tech startup, Airvolt.
That's right. And our mission really is to get under the hood of how this company and their main product, these air monitoring and purification systems, or AMPS, how they plan to tackle, the massive problem of urban air pollution.
But not in the usual way, right? Not just relying on city funding.
Exactly. They're trying to make clean air actually profitable, merging it with high-yield digital advertising. It's a fascinating model.
We should probably jump straight in because the problem itself is just huge and very immediate. We're talking about the air people are breathing now in cities.
Absolutely. Let's set the scene. This isn't some minor issue. It's a full-blown global health crisis.
Yeah.
The WHO, back in 2021, found that 99% almost everyone on the planet lives somewhere where the air quality, specifically fine particulate matter, exceeds safe limits.
99%, that's staggering.
It is. And it's not just about, coughing more. Low air quality is directly linked to something like 7 million premature deaths every single year.
7 million?
Yeah. And if you look at the cumulative impact, it's estimated we've lost, collectively, over 13.5 billion years of human lifespan just because of bad air. In heavily polluted cities, your life expectancy can be cut by 4 years, maybe even more.
So doing something isn't really optional. It feels like a critical need. But the challenge, and this seems key to Airvolt's approach, is that cleaning city air feels almost impossible, right? It's vast, expensive.
And physically difficult. The pollution often gets trapped.
Right.
And that physical trapping is a core technical insight Airvolt seems to be building on. They aren't trying to clean the entire atmosphere over a city.
No, that would be impossible.
Right. They're targeting these specific, localized microclimates where pollution gets stuck.
Yeah.
The first chunk of our source material really digs into this concept of the urban street canyon.
Oh yeah, I can picture that. Like deep streets between tall buildings in, say, downtown areas.
Exactly. Think Manhattan, Chicago, London. The geometry is defined by what physicists call the aspect ratio, or AR. That's just the height of the buildings divided by the width of the street.
Okay.
And in most modern downtowns, that AR is often between 1.0 and 2.0, so relatively deep canyons. And the physics of airflow in those canyons leads to something called skimming flow.
Skimming flow sounds like the air just skims over the top and doesn't get down into the street.
That's a good way to think about it, yeah. For pollution, it means the wind flowing above the buildings doesn't effectively ventilate the canyon below. Instead, you get this single, stable vortex forming inside the canyon.
A vortex, like a whirlpool of air.
Pretty much. It acts like a washing machine, just recirculating the pollutant's car exhaust. Particulate matter right down at street level where people are breathing. It dramatically reduces the natural air exchange with the cleaner air above.
So the wind high up doesn't really help the pedestrians down below.
Not nearly enough. The research shows there's a minimum wind speed needed, this coupling velocity, UCL air, to actually break that stable vortex and flush the canyon out. For a typical deep canyon, maybe AR 1.8, that threshold is surprisingly high, around 2.7 to 3.5 meters per second.
Which is, what, like 6 to 8 miles per hour? Not insignificant.
Exactly. So whenever the ambient wind speed drops below that critical level, which happens often, especially overnight or during certain weather conditions, those pollutants just build up. They accumulate much faster than they can disperse. And these are the stagnation canyons Airvolt is specifically targeting.
Oh, okay, but I have to ask this. If you put one of these AMPS units on a street corner in a canyon where the air is swirling in a vortex, how do you know it's not just cleaning the air right next to it, but maybe making the vortex trap things even more effectively elsewhere? Or just shifting the dirty patch?
That's a really fair point. The feasibility studies seem to tackle this by focusing on where the impact matters most. Pollutant concentrations are generally highest near the ground, in the pedestrian breathing zone, say, the first 5 meters or so. That's where the health risk is greatest.
Okay.
The AMPS units are designed to pull air from that specific high-risk zone, clean it, and release it back into that same zone. The aim is localized reduction of exposure risk where it counts, rather than trying to fundamentally alter the large-scale canyon airflow pattern itself. It's about creating pockets of demonstrably cleaner air.
Got it. So a very targeted solution for a localized problem, which means the tech itself needs to be pretty specific and, I guess, efficient. Let's get into the unit itself. What's actually inside this AMPS box cleaning the air, and how does it avoid being an energy hog?
Right, the purification core. It's designed for the complex mix of urban pollutants. It's a multi-stage process. Stage 1 is mechanical filtration, absolutely essential for the fine particulate matter, the PM Euros. They're using HPH13 filters.
H13, that's high-grade stuff. Captures over 99.95% of those tiny 0.3 micrometer particles.
Exactly. But cities aren't just dust, right? You've got gases from traffic, nitrogen dioxide,
For sure.
various volatile organic compounds, VOCs. So stage 2 is adsorption. They use materials like activated carbon, maybe zeolites, which chemically trap those gaseous pollutants.
Okay, filters for particles, absorption for gases, makes sense. And it moves a lot of air.
Oh yeah. The specs mention a high clean air delivery rate, or CER, typically in the range of 4,000 to 5,000 cubic meters per hour per module.
Wow, 5,000 cubic meters an hour. That sounds like it could use a lot of power if it's running all the time.
Yeah.
If a city deployed hundreds or thousands, the electricity bill could be massive. How do they manage the operational costs, the OPEX?
This seems to be where the smart part comes in. They call it dynamic duty cycle optimization. Each unit is IoT connected. It's constantly measuring local conditions, not just PM Euros and NAO, but also wind speed, temperature, humidity.
So it's not just running full blast 24/7.
Exactly. It knows when pollution is likely to peak, like rush hour traffic, morning and evening, or even say during a nocturnal temperature inversion when cold air traps pollutants near the ground overnight. The system uses that real-time data to modulate the fan speed.
So it ramps up when needed, ramps down when the air is cleaner or conditions are better for natural dispersion.
Precisely. And that intelligent scheduling, according to their projections, can cut the energy consumption and overall OPEX by potentially up to 40% compared to just running it constantly.
40% reduction, that's significant, especially if you scale it up. That must make their energy efficiency look pretty good. They mentioned a specific metric.
Yeah, the specific clean air energy. They cite a value around 0.175 kilowatt hours per 1,000 cubic meters of clean air delivered.
Okay, 0.175 kilowatt per 1,000 meters is. How does that stack up? Is that genuinely good?
It's actually exceptionally good for this kind of application. If you compare it to, say, large commercial HVAC systems moving similar air volumes through high-efficiency filters, their E-spec can easily be 2 or 3 times higher. The advantage here comes from that dynamic operation, cleaning targeted volumes when it matters most, not just constantly churning air.
Yeah.
And that energy efficiency is critical because without it,
The whole economic model probably falls apart.
exactly. Which brings us neatly to, well, the most surprising part of the source material, the economic engine. Outdoor air purification is almost always a cost for cities, right? A public service they have to fund. Airvolt seems to be flipping that script.
How do they turn it from a cost center into potentially a high-yield asset?
Through market convergence, they're positioning themselves right at the intersection of 2 pretty large markets. First, the commercial air purification market, about $16 billion globally in 2023. And second, the much larger and rapidly growing out-of-home advertising market, specifically digital out-of-home, or DOOH.
Right, the digital billboards you see everywhere now. That DOH market is already huge, nearly $40 billion, and projected to grow quite a bit.
So the AMPS unit is basically doing double duty. It's an air purifier, yes, but it's also designed as a premium advertising platform, a communication core, they call it. It includes a large, high-brightness digital display, at least 55 inches.
And the content on that screen is split.
Yeah, the model described as about 70% for paid advertising, and the other 30% is dedicated to showing real-time local environmental data from the unit's own sensors. Air quality, temperature, provides transparency.
So the revenue comes primarily from selling ad space.
Primarily, yes. Selling that DOH inventory, likely on a CPM basis using programmatic platforms, but they also mentioned a secondary stream, collecting and potentially selling the aggregated environmental data via an enterprise SaaS application, monetizing the insights.
Okay, now this is where the numbers in the investment materials just seem almost too good to be true for this kind of project, the financial feasibility claims.
They are pretty startling. The estimates suggest the average yield from programmatic DOH on these units could be somewhere between €9 per hour.
Per hour, per unit.
Per hour, per unit. So even assuming a moderate fill rate, say, the screen shows ads only 60% of the time it's on slank. The annual gross revenue per unit could range from about $31,500 up to maybe $42,000.
Okay, hold on. Annual revenue potentially over 40,000, and we just talked about the OpEx, the running costs being kept low by the smart tech. What was that figure again?
Around $1,700 per year for energy, filter replacements, basic servicing.
So high revenue, very low operating cost. What about the upfront cost, the CapEx, to actually build and install one?
The materials estimate that at around $9,500 per unit.
Right, so if you put that all together, 9,500 upfront cost, potentially earning 30,000, 40,000 euros a year, with only 1,700 in running costs, the simple payback period they calculate is, what?
4 to 6 months?
4 to 6 months. That's
Yeah.
incredibly fast, like 0.3 to 0.4 years. For a piece of physical city infrastructure, that sounds more like software or high-frequency trading.
It is remarkably fast. It suggests a net margin, before you even account for amortization, of something close to 99% at good locations. It completely reframes the unit. It's not a public expense anymore. It's potentially highly productive real estate.
But hang on, if the economics are that compelling, 9K CapEx paid back in a half a year. Why isn't every company that owns a digital billboard rushing to strap a HEPA filter and some sensors onto it? What are the catches? Regulatory hurdles, competitive barriers. Is that payback really achievable consistently?
That's a really sharp question. The sources don't explicitly detail all the hurdles, but you can infer some things. The secret sauce probably isn't just the hardware components alone. It seems to be the integrated system and the value proposition. Airvolt isn't just selling ad space, they're selling verified environmental impact alongside it.
So the clean air function isn't just a feature, it's potentially the key to getting permits.
It could be. Think about zoning regulations for digital billboards. They can be quite strict in prime urban locations. But proposing a unit that cleans the air and provides public health data, which also happens to have an ad screen, that might have a much stronger case for approval in those high-value spots. The environmental benefit might unlock the advertising real estate.
So the clean air is like a regulatory lubricant for premium ad placement.
That seems to be the angle, yes. And compared to competitors, maybe specialized air cleaning trees or similar tech, those are pure cost centers. They don't generate revenue. Airvolt aims to remove that cost barrier entirely by making the system pay for itself and then some.
Which leads us perfectly into the next section in the sources quantifying that environmental and social value. They're not just aiming for financial profit, they're explicitly trying to monetize the ESG impact, which is obviously huge for attracting investment these days.
Absolutely. They're translating the physics of air cleaning into metrics that resonate financially and socially. So based on typical operation, maybe 12 hours a day, they estimate each unit cleans around 19.7 million cubic meters of air annually.
Almost 20 million cubic meters per unit per year, and that translates into actual removal of pollutants.
Yes, physical mass removal. At typical urban pollution levels, they estimate a single unit might remove about 0.45 kilograms of PM euro per year, and somewhere between 0.2 and 0.6 kilograms of N euro annually. Small amounts per unit, maybe, but it adds up.
And they try to put a monetary value on that health benefit, don't they?
They do. Using standard methodologies like those from the WHO, looking at reduced illness, fewer hospital visits, lower exposure risk, they proxy the annual health benefit value at roughly 20,000 euro per unit.
20,000 euros in health value per unit per year, plus the ad revenue.
Exactly. They also frame it in a more relatable social impact metric, clean air minutes. They calculate each unit protects about 500,000, 0.55 million clean air minutes for people nearby each year.
That's a very clever metric for communication and ESG reports. Sounds impactful. And they combine all this value into one overarching score.
Yes, the public value multiplier, or PVM. It's basically their measure of profit meets purpose. It compares the total combined value, that's the environmental health value, plus the societal value, like those clean air minutes perhaps, plus the actual ad revenue, and divides it by the annual OpEx, that 1,700 running cost.
And the result, what's the multiplier?
The result they project is pretty stunning. For every €1 they spend on operating a unit annually, it generates somewhere between 30 and 37 euros in combined public and private value.
30 to 37 times return in blended value. That's a powerful argument.
It really is. It suggests the environmental performance isn't just paying for the unit, it's creating significant additional wealth and well-being for the community.
And clearly the plan is to leverage this PVM, this whole model, for massive scaling.
Oh, definitely. The roadmap outlined in the materials is ambitious. They're talking about scaling to 20,000 units by 2030, deployed across 50 or more cities globally.
20,000 units. If they hit that scale, what's the aggregate impact look like?
Well, based on their per unit estimates, that network could potentially remove over 10 tons of PM euros from city air each year. and generate something like 400 million annually in those societal health benefits we talked about.
That's a really compelling picture. You take this chronic, costly urban problem, air pollution, and Airvolt's model seems to transform it. It becomes a self-financing, even high-yield infrastructure asset class, deploying hardware that delivers environmental benefits and pays for itself in potentially under 6 months. It really could change how we think about funding climate solutions in cities.
I think you're right. And perhaps the most crucial element underpinning all of this, beyond the finance, is the data. Each AMPS unit isn't just cleaning air, it's acting as a tiny, connected micro-laboratory out on the street.
Generating constant data streams.
Yes, exactly. Real-time, location-specific data on air quality, on the unit's performance. They even mentioned using blockchain for anchoring that telemetry, making it verifiable. This data does two things. It proves that clean air is actually being delivered, building trust, and it feeds valuable insights into broader urban environmental science and city governance.
Which helps with regulatory alignment too, I imagine, demonstrating compliance with things like the EU's air quality directives or contributing to UN Sustainable Development Goals.
Precisely. It connects the dots between physical action, measurable impact, and the kind of verifiable data needed for ESG reporting and policy frameworks. Goals 3, 9, 11, 13, 17. It touches on quite a few.
Okay, so let's wrap this up with our final provocative thought for you, the listener, based on everything we've unpacked from these Airvolt sources. Consider this. If clean air, something we usually think of as a free, public good, or maybe a costly problem to fix, can be made measurable, verifiable through data, and actually economically profitable, could this type of model be the future, where environmental performance itself becomes a kind of monetizable asset class, maybe through things like ESG data credits or even tokenized clean air minutes? Is making environmental cleanup profitable the only practical way we're going to fund the massive climate infrastructure needed in our cities? What happens when clean air suddenly becomes the most valuable commodity on the block?
Thank you for tuning in to our deep dive. Join our mission to breathe better ads and improve air quality in cities across the globe. Until next time,